presentation. So this is my thesis topic. So evaluating the performance of a distributed tracing, like how it's behave like in a dynamic workload in a Kubernetes based environment. I'm using different sampling method here. We can discuss further. So these are the presentation outlines. So first, what is motivated to do this topic as my thesis project. So first we need is the architecture. Nowadays, every backend architecture is microservices. So from the monolithic to microservices, so there is one problem we are facing is distributed tracing. The tracing, suppose we have 100 microservices in a system, it's very hard to debug or find which the request go from. If anything happen between the two microservices, which is very untrackable to if any error happen in the which microservices. So that's why we need to implement the distributed tracing system in our system, in our architecture. So the one of the thing is open telemetry. Most developer using that thing. So and in here we are using CPU memory as well as coarse latency calculator in here, and using different sampling method like problematic head-based and tail-based sampling. And the last one is no existing study that cover these three sampling as well as in the Kubernetes based environment. So that's why that motivated me to take this topic. And these are this question and the objective number 1 and 2. First one is analysis of the performance overhead, like in a different sampling, head-based tail sampling, and the problematic sampling. In like find the CPU usage, memory, latency, as well as cost. And the objective 2 is how it affect the different items like steady workload, traffic spike, and the how it's behave in these scenarios. So this is my system architecture. So total 10 pod I run in the Amazon EKS cluster. So first for the React front-end application, and the 5 for the 5 microservices, which is developed using Microsoft Python Flask, and the port 7 as an open telemetry character. We can show the every trace and the spam that get like go to the open telemetry character port 7. All the traces are getting here. If any problem in this microservice path, it directly we can get from this open elementary character. That is one of the advantage when we using such an observatory thing in our system. And this trace is called for the Jagger. Jagger is nothing but we can store that trace in here. We can visualize that trace. And the metric side is nothing but like memory, latency, CPU, all this considered as a metrics we can get from the open telemetry character. We can go for the pointers, we can store it here, and we can visualizing that thing in the Grafana. So Grafana is nothing but we can visualizing that metrics in the website. So in the total 10 port, all the 5 microservices and one front-end code is deployed in Amazon ECR, and get the image from there, and the case it's as a like for my I'm using for the dynamic workload. So I'm using this C7i flex.large work node for my entire thing, which consists of 2 CPU as well as 4 GB RAM. So these are the equations I'm using right now. So like just for the calculation, CPU, memory, latency, as well as cost. This is a proxy cost index, not a real life cost index. So it's just for the like not identical to the Amazon AWS cost. So the important part, sampling configuration. So there are 4 configuration. First is no set tracing. It's nothing but like not even a one request accompanying a system is trackable. 0% is untrackable. So the problematic sampling is 10% is trackable. If suppose 100 requests are coming in my system, only 10%, only 10 number is trackable. 90% is just discard that thing. The head-based sampling is nothing but the 100% of trace is recoverable, 100% of request is traceable. 100 requests that come in my system, 100% or 100 requests is tracked in there. Trail-based sampling is nothing but I'm using 2 retention policy in the trail-based system. first one is 100% of error is traceable, and the second one is only the 10% of success trace is traceable, and 90% of successful trace is discarded. So all so the nothing but the what make the tail based thing is differ from the rest of thing is it's we are using 5 second buffer in here. All the requests are waiting 5 seconds in that tail based system, and after the 5 seconds this open elementary cannot decide that if any error in the system, 100% of the error request is traceable, and if the error request is success, only 10% is traceable, and the 90% is just discarded. And these are the workload scenarios. 15 count virtual user for 3 minutes in a steady, and spike is starting with 5 virtual users, gone up to 30, and reaching the 5 again for the 3 minutes and 10 seconds. The RAM scenario starting with 0, gone 30, and coming down 0 for 7 minutes. So we are using for case load test. So these are the experiment number 1 for the steady load, for the spike load, and the RAM load. When we are comparing this whole thing, we can know that the tail sampling is highest in all the traceable thing, because we are using 5 second buffer in the tail sampling, right? So that's why tail sampling is higher than any case the CPU, memory, latency, as well as the proxy cost indexes. CPU like tail sampling is more, and no sampling is comparatively less, because there is no sampling happen over that no sampling thing. So that's why it's comparatively less than any other else. But there are some anomalies happen here. When we look at here, the CPU utilization, the tail sampling is 25.37, which is greater than problematic sampling. When we theoretically thinking it must be less than the problematic sampling, but somehow because of some anomalies happen, I'm getting value is higher than problematic sampling. So this just considers an anomaly I'm facing. And these are the limitation. Number 1 limitation is I'm using 5 second buffer. Because of the 5 second buffer, I need to be restrict my system. So that's why I stick on the 5 second buffer. So only sampling is deferred in my system. The rest of thing is I disable the auto scaling, I disable the entire thing. Only the sampling is deferred thing. So that's why one of the thing is 5 second. It's not varying, it's fixed to 1, and the CPU utilization is throttling is not calculated, and the SDK installation cost is not isolated from the export cost. Also, the mean is calculated here, not the standard deviation is calculated. So these are the limitations, and the conclusion wise when we are talking, the expected auditing is like no sampling is lesser than problematic, which is lesser than the head sampling, and which is lesser than the tail sampling, where tail sampling is higher overhead. Problematic sampling is the most resource conserving across all scenarios. Both the objectives are fulfilled, the future scope are the same. I need to vary the window size, enable the Kubernetes autoscaling, and go for the Go language as well as Java, because I'm developing Python fast. I develop my system. So this is my GitHub repository. Thank you. Let's move to our demo. This is the Amazon cluster deployment application here. So this is the Grafana interface. So Microsoft need overview, the resource utilization, the CPU utilization for port containers, everything is in here. Only now it's 1.52. And this is my front-end application, and this is a Jagger. We can visualize in the like the trace that happened here. And look at this is the previous one, and we are first auto service payment notification user. We can get in here. We can trace our request here. So let's move on to our thesis configuration. So I'm using token here. I'm getting token and hard-coded here to avoid the logging. And now I'm running with the tracing mode as a tail mode. So just run the steady mode. This is a steady mode configuration. So let's start our steady mode. it's started now. So after some time we can it's expected to rise. Let's wait for some times. It's raising now. Yeah, it is raising now. Let's wait for some time. Yeah, it is raising 3. And one more thing is, and tracing mode is tail sampling. The 5-second buffer is in activator. So yeah, this is how it's odd service, order service, notification service, Grafana, and the Jagger front end, every ports now raising now. So it is 10% as well as the memory utilization is also increased. And now it is in almost 1 minute past. So all the thing is raising now. And when we go for the Jagger, look at the time now, 220 now, which is current rate. All the like the request in getting from here, whatever the request form we can get in here. So this is the Jagger thing, and we just bypass this front end thing. That's why I'm using hard coded my token in here. I'm getting this token from the front end. And now when we are using 90%, it's almost 130 now, and 90% is increased. We can just wait for some time. Yeah, and maybe we can go for this. And look at this, the current request rate is 48 requests per second that happen in the order sampling, odd sampling, everything. And this in the case of here, as well as latency, throughput in the requests per second we can show here. And let's go here, 22.8% I'm getting now in a 15 virtual user. And for the we don't have much time for this like 50%, so I just canceled it now. Now it's reaching to 25, 20, 22%. Yeah, it's increasing 25%. So when we are summating some of the all the thing, we get the total CPU usages. So and as of now we can reduce that thing. Now I need to change that into the head-based sampling. I'm going to change now. This is my power script thing, and changing tracing mode as a head, and I'm updating every configuration file and re-upload that thing. All the ports in my Kubernetes is restarted, and checking now. This is all the previous ports are terminated, new ports are restarted. Let's wait for one or 2 minutes. Maybe it will be restarted again. Yeah, it is, all the previous thing is terminating. Yeah, only 2 is terminating, 3 is terminating. Yes, now look at this, every pod is running right now. The 43 seconds ago the pod is running, because we just changed like tail sampling to the head sampling, so that's why we need to update the configuration file as well as. So let's move to the next. We can go for the spike thing, which is highest. We can start from 5 to 30, and this is when we are starting this. This is also in. We can start with one virtual user. Look at this. Now look at this, reduce into 1%, because there is no request that coming here now in our system. So just waiting some time. It's keep increasing. Yeah, it's increasing now. Yeah. Now my system is running on head-based sampling. Head-based sampling is nothing but there is no buffer thing. Only 100 percentage of the request is traceable. Whatever request I'm coming in my system is traceable, but exclude that like there is no 5-second buffer. So now my system is increasing now. It's almost 15 minutes. Yep. Yeah, my system is rising. The CPU usage is increasing, and the overall memory is also increasing. Now it's increasing right now. Also, when we are looking in the Jagger, we can know this is a current right now to 2590 second. Like this, I'm getting the correct because yeah, I'm getting the correct. I'm also getting the tracing here as well as yeah. Now it's head sampling. It is raising now. Now, why exactly is the previous we are running the steady thing, right? Steady configuration, but in here we are using 30 virtual user. Now we are using, that's why this is spike. We reached for 48 right now. That is why this is because we are using 30 virtual user, but it is decreasing now. Maybe it will decrease by now. Just wait for some times. Also, the total spam is also increased. Spam is nothing but the trace. Like in whatever the microservice is gone, the trace is generated over there. Like look at this because there are in the each microservices, and the CPU usage is now reducing. Not reducing. Yeah, it is. It will reduce. Yeah, it will reduce. And the research dashboard as well as this is research dashboard as I am getting the P50, P95 and P99 latency. I'm getting from here. So I'm sorry to mention before earlier. So now the pod is decreasing right now, and my system is going to end. Either entire 3 minutes is going to an end. Yeah, it's right now the entire request is 15.86 per second. It is all on 3 minutes, including the starting from 0 to 30 and 30 to 0 altogether. So now it's decreasing right now. So this is my entire demo project, how it's behave in the different sampling. Now you will understand the entire concept of my thesis project, all those things. Thank you so much.